Okay, we are recording. So, welcome everyone. This marks our fourth day of the class, second week. We are going to continue our conversation with networking. It looks like we have one more day of networking, and then we're going to jump into Kali Linux, and we're going to learn about how to navigate through a Linux operating system. I won't go into too much detail talking about Linux now because we can save that for Wednesday. But again, to reiterate the importance of having VirtualBox installed. So VirtualBox will be important for us because that's going to allow us to do our next group of projects. And in short, what you are seeing here, this is what y'all's stuff should look like. So again, I can spend a little bit of time troubleshooting with you guys on how the installation and getting it all done, and we'll have some time today. But I'm only allowed so much time for lecturing, and that'll be the focus, unfortunately. A lot of the pre-work, this installation and stuff has to be done on your time or with your mentors if you're having issues with it. Again, I'll help as much as I can with the time given, but the focus in these courses during these class times will be the lectures, of course. But if you have something similar to what you're seeing on my screen, this is where we want to be. For tomorrow or Wednesday, we're going to be navigating the CLI, also known as the command line interface or the terminal. And this is essentially navigating through an operating system. That's one of the things about Linux is although this is point and click, there are what's known as headless operating systems in Linux, which basically there is no mouse, there is no point and click. Everything is just straight up typing. So if that's the type of thing you like doing, if you like to, instead of just, using a mouse and clicking around and pointing and clicking on what you want, if you don't like that and you like to manually type everything out and you like to navigate to this directory, to that directory, then Linux is for you. But by Wednesday, you should hopefully be able to have the ability to have this right here. And then we'll play around. Yeah, we'll play around here, and then I'll show you basic commands of how to navigate through this. And yeah, Teresa, go ahead.
Okay, so I have the VirtualBox up, but I don't have that Kali Linux in this little section. That
Okay.
When
Did you go to? So I'm not sure which one yours looks like, but when you go
it looks just
to,
like the one that you have.
yeah, okay. So it has all the stuff where you need to go to download. So if I go to here,
This is in the pre-work, correct?
this is in our just our regular tab. This is in our regular stuff right here. This is in our daily coursework. This isn't the pre-work.
Okay.
This is the normal one. Debian. If I click on here, click on this hyperlink. Let's see what shows up.
Is it on the network architecture?
Yeah.
Or it should...
Yeah. So see where it says right here, Windows and Linux Kali. So you're on a Windows, download the OVA file right here. So this is the Debian one. But I had my own download Kali Linux from here, downloads. There you go. So did you see how to get there? Teresa?
I'm seeing like how to start this project. Yeah.
Okay, so
So
walk through me on the here with me. So because this is where you want to download it, and that's what you're gonna want to do next. So are you see where it says network architecture? Are you here?
okay, hold on. Let me go back to the front of the screen. I want to get there. Okay, network architecture. Yes.
Okay, and then do you have this one where it says project right here?
Correct. Yes.
So click on that one.
So okay, click on what? You said click on that one. That one what?
The
Open locally in
project.
computer.
Do you see this project
Yeah, I
right here?
opened that. Yeah, I already opened that. Yeah.
Okay, so click on this Debian installation instructions right here.
Okay. Installing Kali Linux on the virtual
Yeah.
machine.
So click on that one right
Okay.
there.
Okay.
And then do you have this?
Yes.
And then where it says download Kali Linux from Kali.
Yeah. So there's two. This is top download VirtualBox from download. So don't. So am I gonna do the second or first one? Oh,
So you already have VirtualBox. You said you downloaded that one, right?
yes.
Okay. So you're going to want to download the Kali Linux. So click on downloads.
From the VirtualBox.
That link I just showed you.
Oh wait, I didn't. I'm using two screens, so I wasn't looking. So download Kali Linux from Kali Linux.
Yeah.
Okay.
Let's see. Install images, virtual machines.
So which one am I downloading?
So click on all packages are downloaded during installation. I would
I'm
click
sorry
this
about
one
that,
right here.
guys.
Oh, that's okay. So just click on that one right there where it says installer. Do you see it?
Installer images.
Do you see my mouse right here moving around?
Yeah, but which one did you click on from the other one? There was installer
So
images.
installer images. So click on installer images right here.
Okay,
Did you click that one?
I did.
So click on that and then click on this one right here. That download right there.
Okay. Okay, that's downloading.
Okay. All right.
Okay,
So
so
we're going to jump in today's topic.
thank you, Mr. Cody.
Yep. So today we're talking about network architecture. And Rose, you can see and hear me okay?
Yes, I do. I apologize. I went to pull the cord and I
That's
unplugged the
all
whole
right.
thing.
No worries. Is your stuff, is your keyboard working now? Are you able to type the
Yeah,
right
I
letters?
tried it. It's working now.
Okay. Well, let me go through this first since I already got pulled up, and then we'll share your screen and we'll make sure
Okay.
your stuff is good. This will go pretty quick. We only have this little bit, and then we have introduction to VirtualBox, which we've already been talking about a lot. So unfortunately, this stuff is in Spanish, so it doesn't do us a whole lot of good. But hopefully, we can use the icons and we can figure it out. But it's all pretty straightforward. Okay, so network planning and documentation. So when it comes to network architecture, that's really what it is. It's during your life cycle phase. This is going to be known as like scoping, discovery, design, documentation, planning. That's all the most fundamental important aspect when it comes to any type of project we're doing. And again, this is outside of the scope of cybersecurity. Why we're really delving into this, I'm not really sure. but that's okay. I'll still teach you about it anyways. But in short, network planning and documentation is an essential process to ensure effective design, implementation, and maintenance of a network. So some of the key concepts, creating a strategic plan for a network, different types of topologies, which we've already spoken about. 9 times out of 10, it's only going to be one topology. It's going to be your mesh. Do you remember why it's going to be mesh? I spoke about it a couple times, why that's the most applicable, useful one out of all the different topologies we've spoken about. Does anybody remember why mesh is the most obvious choice for any type of network architecture? Anybody? Who remembers what DRHA stands for? I said that quite a few times. Disaster recovery and high availability. Why is that important? So in cybersecurity and anything, if something goes down, you want to have a backup, right? So let's pretend that you want to go to Amazon and you want to buy, the latest whatever. And you go to Amazon and guess what? Amazon is down. It's not working. That'll never happen, right? But think of Amazon as a company at that level. If your services are down for any length of time, a couple minutes, a couple hours, a couple seconds, you're potentially losing millions upon millions of dollars, right? So that's why high availability and disaster recovery are so important. Because if you were to be DDoS attacked, if you were to be cybersecurity attacked, if there was some type of network problem and your website is not working properly and people cannot utilize your services, then that means you're going to have a loss for money. So you need to be able to prepare and plan for that type of stuff in the event that when you do get attacked, when you do get DDoSed, you have a failover. And so you're not losing all that money. Does anybody have questions on that concept?
No.
Good. Pretty straightforward, right? So that's why when it comes to network planning and documentation and design, you need to factor in all those types of things that I just mentioned. So in case something goes down, there's something known as threat modeling. And there's different types of threat models that you can apply to. One is called STRIDE, one is called PASTA. STRIDE, the acronym STRIDE stands for non-repudiation, information disclosure, DDoS, elevation of privileges, denial of services. And so those are different attack vectors that you have to take into account when you're doing your design for your network planning, because those are different attacks that hackers are going to try to apply to you to bring down your system and bring down your services. So there's different types of modeling architectures that can be applied to your planning to adhere to those different attack vectors. And so you have remediation and redundancy in place to address that in case it does happen. And usually it's not if, but when. It's always going to happen, but it's important that you're just prepared for it. So that's why the network planning and the documentation, that's going to be your backbone to everything that you do. So it involves creating a strategic plan that defines objectives, requirements, resources needed to build and manage a network efficiently and securely. So an example, real world, would be if I'm a security architect and I am working with a client and they want to build out some new cybersecurity solution. Well, I'm going to do all the scoping, discovering, design, and then I'm going to work with program managers and develop what's known as a project plan. And in that project plan, it's going to list everything when it comes to the planning. It's going to identify your stakeholders. It's going to identify timeframes. It's going to identify budget. It's going to identify objectives. It's going to identify all the aspects associated with building out this infrastructure. And that's all established within your project plan. It involves identifying the specific needs of the organization, such as the number of users, services required, and is expected volume of traffic. Likewise, It involves evaluating the available technologies and selecting the most appropriate ones to meet the needs of the network. So within that network documentation, you're going to have diagrams, an inventory of equipment, and again, the project plan that I just mentioned and all the other aspects associated with the planning. Documentation can help us take a more systematic approach to troubleshooting the problem to get back up and running and possible. So that's part of it, but documentation more or less addresses all aspects of your network. So acceptable use policies, the different type of applications that are going to be in use, your SLAs, and how you respond to different attacks, and who's going to be involved in it, and who's associated with it, and what your methods are for addressing those. For a network administrator to monitor and resolve these network problems, it's necessary to maintain proper documentation. So configuration files includes network and in-system config files, physical and logical topology diagrams. So network schematics, also known as reference architecture, that's going to highlight and identify just how it sounds, your whole network and all of the attributes associated with it. It's all going to be in a nice diagram for you, or it should be at least. With this information, a network administrator can effectively diagnose and correct network problems based on the design and expected performance of the network. So network configuration files, also known as comp files. These files contain accurate and up-to-date records of hardware and software used on the network. So comp files do a lot of stuff. This is only just a small aspect of it, but let's see what ChatGPT says. Let's see what ChatGPT has for us. So config files, commonly known as a config file, defines the parameters, options, setting, and preferences applied to an operating system, infrastructure devices, and applications. These files, typically written in human-readable format, can be edited using basic text editors. They allow users to customize how an application interacts with the system or how the system itself operates. So a good thing about configuration files is if you're building out a big, huge infrastructure with a lot of moving parts, you can develop a single configuration file, and then you can run it multiple times, and you can build out a infrastructure very quickly, very fast, and do it the right way without having to reinvent the wheel every single time. These are some different types of config files. So any JSON, JavaScript, object notation, YAML, XML, extensible markup language. Examples of config files, application settings. Applications often use config files to store user preferences such as themes, language settings, and default paths. So an example would be if you have an IT administrator at a company and they're issuing laptops for their employees, they're going to want to have a certain operating system. They're going to want to have a certain applications. They're going to want to have certain group policies associated with it. They're going to want to have certain things configured and defined for that particular user. And so they'll use conf files to very easily run them within a laptop or an endpoint, and allows it to very quickly provide all the elements that are applicable to the company's acceptable use policies, and it makes life very easy, or much easier than it could be. So some examples, server configuration. Servers use config files to define parameters like host names, ports, and security settings. Database connections require config files to specify details, user credentials, operational. Proper management of config files is crucial for the stability and security of systems and applications. It is essential to ensure that sensitive information within these files is protected, that changes are tracked, and often through version and control systems. So some some data that might go into a config file, as mentioned here, where you have ports, you have IP addresses, you have a whole list of stuff. Likewise, these are some examples. So you would have a device name. This looks like a Cisco router. You're going to have the MAC address, the IPv4, IPv6. This list will help us, as a misconfigured in system can impact negatively on the overall system performance. It's very useful to have a baseline log showing the hardware and software used on these devices for troubleshooting purposes. So a lot of times you're not going to use a config file to do troubleshooting. You know, that would be done with logs and endpoint protection tools and stuff like that, network monitoring tools, stuff like that. Config files are more for configuration and management and setup of the infrastructure. More about network topology and diagrams. Network topology diagrams keep track of the location and the function and the status of the devices. So a lot of times diagrams also referred to as schematics and reference architectures, more appropriately the terminology used in the industry, but that's going to, again, identify location. It's going to identify things associated with asset management. Physical topology. Physical network topology shows the physical distribution of devices of the network, as we just covered. So device type, this isn't often going to be in a config file. Sometimes it is, but this is more associated with asset management. So anytime you have a company that has a lot of endpoints, you're going to have a program known as asset management. And that just how it sounds. Every single asset, any type of phone that's issued, any laptop that's issued, any server that's issued, you're going to have a whole host of information associated with that. It's going to tell you who owns the system, what the SLAs are, what the operating systems are, what the critical applications are, what the failover is. All of that stuff is going to be identified in the asset management. A lot of times it happens. I don't see it very often. It's usually not too detailed, but if you can, they tell you what type of connector types, cable specifications, and all that type of stuff. And oftentimes when you have reference architecture, it's going to use symbols to represent different network elements, such as the routers, the servers, the VPN connectors. It would have been nice to have them show you what those symbols are, but let's see. Let's see if ChatGPT can show us. Let's see. Yeah. So do you guys see these logos, these icons right here on the right?
Yes, I can see them.
Yes.
Yeah. So whenever you're creating reference architecture, let me pull up a. Let's see if. So anytime you're creating reference architecture, you're going to use logos and icons similar to this, and that represents a various type of item. So as you can see, this isn't the best picture, but this kind of gives you an idea. So out of reference architecture, you're going to have a bunch of different icons, and they're all going to represent different things. So you're going to have different icons that are going to tell you different symbols like site-to-site VPN, router, servers, hosts, everything like that. Network growth and planning. It's also important to understand that one of the most important characteristics in the design of a network is that it's scalable. And so I talked about this before in our last class. This will ensure that the quality of service of networks is optimal and can continue for function despite high demand for user growth. And so when it comes to creating these reference architectures and these config files, you have something known as change management. And it's important that anytime new changes have been made to the network, anything like that, that the reference architecture and your config files are updated accordingly to match the scaling and the growth of the network that's occurring and the scalability of what's going on. For a network to be scalable, it's necessary to take into account the ability to adapt, focus on increasing network capacity and adding more access points, or to generate hierarchy networks. The use of cloud services, combining several ports into one and looking for a wireless solution will also be key to expanding. To support a large, medium, and small network, the network designer must develop a strategy that makes the network available and scalable efficiently and easily. Includes the following recommendations. Use expandable modular equipment or cluster devices that can be easily upgraded or increase capability. Device modules can be added to existing equipment to support new features and devices without requiring major upgrades. So in today's day and age, everything is usually done by cloud, and hopefully if you can do it in the cloud, again, as we spoke about last time, to do it in the cloud, because there's a huge difference in cost. If you're having a bare metal facility where you have a physical firewall devices versus a virtual firewall device, the ability to manage it, the ability to scale it is going to be much cheaper and much more cost effective and much easier, for obvious reasons, right? If it's a matter of just going into a portal and clicking on some buttons and doing this and doing that, it's going to be a lot easier than having to drive to a facility, have screwdrivers, pull apart entire racks, do cabling, shut everything down. Having been on both sides of the spectrum where I've done it bare metal and having to do it manually versus being able to do it in the cloud, where changing out a firewall can take anywhere from 6 months to a year in bare metal versus being able to do it in 30 minutes or less in a cloud infrastructure, tells you everything you need to know, right? So if you can build it out in the cloud, it's going to be much faster. It's going to be much cheaper. It's going to be much easier to manage. Any questions on that part? That's a really important aspect to keep into consideration with this. Does that make sense to everybody?
Yes.
Okay. Best practices for network management. Design a hierarchical network that includes modules that can be added, upgraded, or modified as needed without affecting the design or other functional areas of the network. So, for example, create a separate access layer that can be expanded without affecting the basic campus network distribution and layers. Create an IPv4 and 6 addressing hierarchy strategy. Careful address planning eliminates the need to readdress network support. Choose multi-layer routers or switches to limit broadcast and filter out unwanted network traffic. Network management systems can manage network devices such as switches, routers, access points from a remote location. Network administrators and managed service providers can monitor network operations by accessing the server, which gives them a great deal of control without having to go on site. Good management can allow us to clear network visibility. IT professionals should get a clear picture of all connected devices on the network, observe data flow quickly, and identify and remedy problems. More efficient use of IT resources can implement tools to reduce the amount of manual labor required. Future infrastructure needs. Network monitoring systems show how network components have performed over some time, giving it insight into the future. And increased protection against security threat. Network monitoring establishes a baseline of a network's performance. This makes it easier to detect unusual change in network behavior. So anytime you build out a new network, what you're going to do is what's known as baselining. So what you'll do is you will essentially, for a week, when you first build out an infrastructure, you'll baseline it. You'll spend 5 business working days, and you'll monitor the total amount of traffic, ingress and egress, traffic that's coming in and out, and you establish that baseline. And then as you move forward over the weeks and months, if there's ever a deviation in that particular baseline, that's going to give concern that there might be some type of compromise or some type of threat on the network that is impacting your data flow in some way. And so that's why having a baseline is critical to your security performance. All right, so that one is that. Who has questions there? Pretty straightforward stuff. So now we're getting into the VirtualBox. Again, VirtualBox is a powerful tool that allows us to run operating systems completely from the comfort of a window. So when they say that, looking at this, just how does it sound? So I have my computer right here, right? And there's an underlying operating system here. And then I have VirtualBox Manager, which essentially allows me to create another computer within a computer. So now I have another operating system, Kali Linux, or any type of Linux. I can download any operating system and install it and run it. And basically, I'm running multiple computers within the same computer. Does everybody understand that concept?
Yes.
Yes, I've done that before.
Okay.
Is this one of the other ones that I had to download?
Yeah, Rose, so that's what we were talking about earlier. I was asking you to type in VirtualBox to see if you downloaded it. You said you downloaded it twice?
Yeah.
Okay. So yeah. Let me get through this real quick. It'll go real quick, and then we'll do a screen share with your stuff, and we'll see where you're at there.
Okay.
So VirtualBox, let's see. It's also very useful when studying how these operating systems can interact with each other and computers on our network. VirtualBox offers a variety of interfaces that can be added to the machines to interact in a particular way depending on the scenario. So we could essentially create out, I only have one operating system running, but through what's known as network address translation, this right here, we can create multiple, essentially a lab to where I could have multiple operating systems running, communicating with each other to some degree. And this is often good for troubleshooting, especially if you have a new type of tool or security tool and you want to test the functionality of the tool. What you would do is you would have an operating system and say, I would compromise this. I would put some type of malware attack on it. And then I would have another operating system running the tool, and I would see how the two would interact with each other, what type of responses and remediation I can get, any type of logging or information I could get on the compromise. So it's really good for testing and doing it in a relatively cheap and effective manner. So what is NAT? Just how it sounds. NAT is a service that is the acronym translate private IP addresses into a public one that can connect to the internet. This is what allows a home or office network to have internet connections for many computers with private addresses using a single public IP address for all of them. While this saves IP addresses, it comes with a limitation of not being able to receive spontaneous connections directly from the outside network. To achieve this, technology such as proxies must be used. These requests are to be fulfilled, which is why public addresses are highly sought after commodity in the technology world. Imagine you're building a network and each apartment in it is like a device. NAT is like the building doorman. Outside internet friends can directly enter the apartment, but they can talk to the doorman. In the same way, when an inhabitant needs to leave, the doorman opens the door to the outside and identifies him. So what is NAT good for? Saving IP addresses. There are a few IP addresses, so you can share multiple to one. Security, NAT helps protect your network from intruders by blocking spontaneous access to that device. And privacy, NAT hides your private IP addresses. So when you come into VirtualBox and allowing the adapters, again, unfortunately, this is in Spanish, but from the configuration window of the virtual machine, we can activate up to 4 network interfaces. Each of these interfaces can emulate a specific adapter and connect to one of the available options. The interface uses a private IP on your virtual machine, which translates to the host computer network. This allows you to access the internet from the VirtualBox computer using the host computer's network without exposing the virtual machine to the external connections. This is ideal if you want to access the internet from the host machine without further complication. So if I wanted to configure that, I would go into my VirtualBox manager. I would click on settings. And it's all grayed out because I have the computer running right now, but I would go to network. And here I only have one adapter because that's the way it's set up now. But if I wanted to, I could have something similar to this right here, to where there's multiple adapters. Of course, this is beyond the scale of cybersecurity, so I won't go into too much depth, but bridged interface, which we just saw right here. My option for a bridged adapter right here. This connection uses one of the host system interface directly to connect to the network. In this case, the virtual machine bypasses the restrictions of the host system and appears on the network as another device. Host-only network, similar to an internal network, in that it's a private connection between the virtual machines, but with the exception that the host system has access to the network. A virtual interface is installed that will be connected together with the other virtual machines in this network. By default, this network is isolated from the external network. So that's that. So creating a NAT network on a VirtualBox, it's real easy. I just showed you, but you would go into here, go into your settings, and then you would just play around with the settings to do it. If I click this, this is for cloning. I'm not going to do that on mine. It may not be necessary. Again, this is beyond cybersecurity. If you want to work with your mentor on cloning, I don't think it's necessary for our projects, but I guess it's good to learn if that's something you want to learn. Okay, so where are we at? We're gone for an hour. All right, so we still need to figure out, we still need to get you guys just to make sure you have VirtualBox installed to begin with. So the lecture is over. I'm going to end this recording now, and then we'll troubleshoot on your stuff for VirtualBox. So let me end the recording.